Hello, everyone. Welcome to another Fabric Coffee session at Microsoft Fabric Cafe. My name is Merdad Abdullahi, the community lead and the organizer of this great community. So, in the meantime, uh, feel free to say hi in the chat and let's get know each other better. Cool. I'm super excited to have another session in Fabric Cafe. Karima, we're live now. Let's confirm if you're still here. Actually, we started 1 minute late. My apologies. And let me share my slides as usual. Today, June 21st of 2025 at 7 a.m. in Pacific time. The session number of 37 Fabric Coffee session at Microsoft Fabric Cafe. Let's kick it off. So for those who doesn't know us, we are part of Microsoft Learn community. The Microsoft Learn is the richest and biggest place to just talk about, provide learning and documentation for all things about Microsoft and Azure. And of course, there is a community and is a tech community basically, which has the learning groups, and then you can just connect to your learn experts and your peers, by joining those groups. And Microsoft Fabric Cafe is also a group on the Microsoft Learn community, Microsoft Tech community, and which with over 4,000 members globally. We are a global community and group, which is kind of focusing on Microsoft Fabric and Power BI. So we provide learning and support to Fabric users in all levels. It is a forum for everyone to learn, share, and grow skills together. Here are our social links and addresses. We have YouTube channel for all the past sessions, upcoming sessions. We do the streaming there. You can always just go in the channel and rewatch the sessions, including this and the next sessions. Our LinkedIn page, where we do our announcements about the community, the sessions, and also the updates from Microsoft Learn and Microsoft Fabric. And we also, as I mentioned, we are part of the Microsoft community group. So you can just join our group there as well by following the URL of tinyurl.com/MS-Fabric-Cafe. The meetup group that we have for announcement of the sessions, where you can rate the sessions and rate and just show your presence. It is nothing than just a announcement again, and but we different than you can just rate the session. Just make sure you're going to rate this session as well once it is done. And you're saying it correctly if have been with us. Reddit, we just moved to Reddit. Added Reddit to our social network with the name of Microsoft Fabric Cafe. Feel free to join there as well. This QR code is going to land you on our LinkedIn page. So we are just trying to cover everywhere. Awesome. There's a code of conduct for our community when you're attending the sessions, both online or in person. Thank you very much in advance for adhering to these code of conduct. Respectful, collaborative, collaborate, embrace diversity, stay professional, act with integrity, use responsibly, and report any issues if you see. Thank you very much. Our previous session with Sumesh last week that was related to uh, data ingestion using Apache Airflow, which was basically Airflow job in Data Factory. It is available on our YouTube channel. Feel free to rewatch it. And for today and next week, we have Markus. We have Markus talking about Power BI for today. And I'm going to just invite him to the stage. I don't want to talk a lot. So, hello, Markus.
Hello, Milab. Hello, everybody. Just read that, Karim, it's the first time for you. It's also the first time for me. So we have something in common. Very good.
That's good. Good. Thank you very much, Markus. Markus is from Austria, and which is great to have you here. Welcome to Microsoft Fabric Cafe, and thank you in advance for sharing your knowledge with the community. It is really appreciated. The time that you experts actually put for the community, it is truly appreciated. So, guys, let's see some comments here. Rima, hello from NC. NC, what's that? New York? No, NC. Just let us know. What does this stand for? I don't remember. So, Karima, yeah, it's your first time at Fabric Cafe. Yeah, for those guys who doesn't know us, we have weekly sessions in Microsoft Fabric Cafe. We try to have it, every Saturday, every weekend, let's say. But since May, we started to have, sessions in different time zones to make it more afford actually achievable for most of the attendees around the world. So we are a global community, and we need to be available. Oh, yeah, thank you for making clear. North Carolina, awesome. And just started Microsoft Power BI course, Karima. Yeah, that's good. You're in the right place. Awesome, cool. Markus, I don't want to waste more time. Oh, okay. We have one more. Hello
Yeah.
from Bangalore, India. Awesome, awesome, cool. Guys, feel free to ask your questions from Markus during his presentation. I have the permission to interrupt him, and
Anytime.
and yeah, and this session is going to be recorded for sure. And so it will be available on our YouTube channel as well. So yeah, the first time also for MD, and we have from Bangladesh MD. Hello from sunny and warm Copenhagen.
Hi. Hi.
Is it
Copenhagen.
is it warm now, Copenhagen? How warm is it? What do you mean by warm?
So I guess
Okay.
it's like a few degrees colder than in my place, because Copenhagen is like just north of my place. Today
Yeah,
we have like 24 in Austria. Yeah. So
yeah, you're in the same time zone. Just
24.
passed PL
Oh,
300.
cool. Cool.
Awesome.
Yeah,
Yeah,
okay.
yeah. Rahman, yeah. Well done. Congratulations. Cool. The stage is yours, Markus. I'm
Okay.
gonna be in the backstage, and if there is anything, just give me a shout.
Mhm.
And yep, guys, enjoy it, and let's learn from Markus.
Yeah, very good. This session is about 5 things you need to know when learning DAX. And actually, it's like the 5 things. I mean, 5 things is like 5 fingers on your hand, right? So 5 fingers is usually sort of easy to remember. And I picked those things I had wished for that somebody had told me when I started with DAX. So in the beginning, I had several misconceptions in my mind and had several troubles, and I wished for that somebody told me exactly this what I am going to tell you. So hopefully it's easy for you to learn DAX or come further in a faster time frame. Where's my mouse? Here we go. Okay, let's start. So the important thing is like 5 things. The first thing is that calculated columns are like similar to Excel. If you know how Excel formulas work, you already know how calculated columns work. Measures, this is very interesting. Measures are filtered. We will talk about this in detail. I will do a lot of demos, so I will have some slides, but most of the concepts I will show you in actual demos. So measures are filtered. This is also really, really important. Columns are not filtered. What is meant implicitly here. And measures can behave like Excel formulas, but by default they do not do. Again, I will resolve this sentence throughout the remaining 48 minutes. And as a DAX author, as somebody who writes a measure, you can control filters. This is also something which might come like a surprise, because if you build reports, like the users do filters, like they can cross filter between visuals, they can add slicers, they can use the filter pane. But as a DAX author, you can also control filters and thereby let items disappear or appear as you want to have them. And the most important thing is, in the end, the calculated columns and measures are completely different things. The easier or the earlier you learn about that and accept this fact that just the language is in common, like it's the same language, but the way how they are calculated and how they are done and what are the consequences is rather different, right? I'd like to make a sneak preview. I try to avoid calculated columns and calculated tables in the things I create, in the models I create, because those are legacy, right? The first version of Power BI, this wasn't Power BI Desktop, but Power BI Power Pivot add-in for Excel 2010. Not sure if anybody of you used this tool or heard about the tool. There was an add-in for Excel, and there was no Power Query. So the only way to add something was calculated columns and calculated tables. Now we have Power Query. So if you add columns or tables, you should use at least Power Query or create those tables and columns already in the data source. So let's start. Columns behave like Excel. So this is like the easy part, learning DAX by using calculated columns. So I'm not using them in my production semantic models, but to explain how DAX works, this is easy with calculated columns, because this is like Excel. We have like this expressions. It's called data analytics expressions. That's the name here. And they came to the world, was born with Power Pivot for Excel, and still live on in Power BI Desktop and Analysis Services Tabula and Fabric and all the semantic models. What Microsoft calls semantic models is are queried and created and added on with DAX. And DAX is also like influenced by other languages, because there were already a lot of languages when like 10 years, a little bit more, right? Power Pivot, maybe, I don't know, close to 15 years maybe. Excel was already there, right? So Microsoft decided introducing a new language, DAX, and then use the same syntax like in Excel. It's function-based. So we have like a function call, and then you have parameters, and pass in parameters to a function, and a parameter itself can also again be a function. And even 100, more than 100 functions have the same source code, I was told. I didn't see them, but I just believed it, right? Then from SQL, if you have learned SQL, if you know SQL, then you know that this like this relational functions where you join tables with each other. We can do the same in DAX, but usually we don't join things in DAX. Usually we create relationships in the semantic model already. And there's also something which nobody in SQL calls row context, because there's only one context in SQL, and this is the row context. This means if you write a select statement, select blah 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 from one table, right? And the blah 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 is maybe the first name, the last name, and then concatenate the first name and the last name, then you get one row in the result set per row in the table. And for all those rows, you get like the first name, the last name, and then those concatenated, right? And this is the row context. Everything is like evaluated row by row. And we have the same principle also in DAX. From MDX, they took over the concept of measures. This means that we can have formulas in the semantic model which are not calculated row by row, but like add up things, work on aggregated values. We'll see this in action in a couple of minutes. Then also in MDX, you Usually, I'm not sure even if you can join things. It's a long time ago that I used MDX, but I don't think you can even like explicitly join two tables with each other. Everything is implicitly joined by the information you put into the database. So you have also like these relationships in the multidimensional databases, and the MDX, the language is just depending on these definitions. And then there's something called a filter context. This means if I define a measure and say like calculate the sum of my sales amount, the filter context guarantees that it's not the sum of the sales amount of the full table, but only of the rows I selected, right? Maybe I put a filter on the year for a certain product group or whatever, and then I only see the sales amount for this year and the product group. Or if you put something in a pivot table, in a metrics visual, in Power BI, you have like different product categories and different years there. Every single cell in this pivot table, in this matrix, will show you a different value because there's a different filter context, different categories, different years, and it's also calculated like for the totals, the row totals, the column totals, and the ground total. What's new in DAX is that you can transition between the filter context and the row context, and this is one of the most important concepts and most of the most hard things you have to learn and accept and really make your own. Right? That's very very important. Context transition. Yeah, the language is used for measures, calculated columns. That's what we're looking at in this remaining 40 minutes. But you can also create calculated tables. You can or must use DAX in row level security, and you can write queries. The syntax is easy, as we will see in a second, but the semantic might be complex. So there's sometimes you can write the same expression like very differently, but internally it's the same thing. So it's doing the same thing, even the code is different. And sometimes it's the other way around, that it's just a little thing, and suddenly the DAX measure calculates totally different, delivering a different calculation or result, or has a different performance. And this is really hard to master at the beginning, that you accept these differences and know about those differences. It's getting better and better, but might be confusing in the very beginning. So in Excel, we have this function-based syntax, also in DAX. So you write the if, it's not a statement, but a function. And we ask then for if the sales amount is lower than 0, then we return blank, which is like null, non-empty value, an empty value, non-existing value. If it's like 0 or above, then we return the sales amount. And in Excel would be very similar, right? Instead of like this column references, you would have like cell references, because Excel is not a reporting tool. Excel is not a database. Excel is a spreadsheet, and we have those references to different cells inside the spreadsheet. And DAX can refer to columns. This is the case here. So you have like the table name. Sometimes we need those single quotes. Sometimes you can omit them. I try to always write them. And then we have the column name in the brackets, right? And there's a lot of functions which are really equally, and then we will just start into not too much of those functions, but like take the example of 3 different calculations, because adding like working on string manipulation and so on, this is very well documented. You will easily find out how this works. But the hard thing is doing the calculations. This is what I believe that we should concentrate in the remaining time here. So I will create 3 calculated columns, one for the sales amount, the margin, and the margin in percent. And let's jump over to my demo machine. So I have like this very, very complicated, no, it's very, very easy data model. I have like a date table with 2 years. I have a sales table with 4 different rows, not more, and only 4 different products. Only 3 of those products, 100, 220, I actually used in the sales. And this is also very important that you think about this. No, I do not want to restart now. Also very important that when you try out complicated DAX measures, that you work on really easy demo data and example data. Because if it's very complicated, already the data model is really complicated. It's really hard to find out if the DAX measure is really working on the right things. So reduce the complexity of your data model, or the data at least, when you do complex things. And the calculations I want to do is like the sales amount, which is the price times quantity. The margin is the sales amount minus the costs, and the margin percent means the margin percent of the sales amount. So I divide the margin by the sales amount. And this is what we're going to create right now here. So in my sales table, I will create a right click and create a new column, and then create this sales amount column, which is sales amount, which is just the price, right, which is the sales price, the sales table, times the quantity, right? And if I do so, it's easy to see here. If I zoom in, right, then we see now there's like the quantity is 3, the price is 10, 3 times 10 is 30. 1 times 20 is 20, 4 times 30 is 120, 100 times 5 is 500. So this works, easy to demonstrate in this data view. If I add the margin, which would be the margin, would be the sales amount, which is just calculated, sales amount, minus the total costs, right? Which is just, as you would in Excel, it's just column references. Or if you mark something as a table in Power, not in Power BI, in Excel, right? You have the spreadsheet and you have your worksheet, and then you mark something as a table. Suddenly, the formula is also not referring to cells, but column names. It's the same here in DAX. Rather easy to understand, I think, I hope, right? And the last one would be the margin in percent, which is the margin divided by the sales amount, right? And then we can format this as a percentage, and then we get this as nice numbers here, 60%, because 5 divided by 30 is 16%, or 5 divided by 20 is 25%, and we get this like multiplied by 100 automatically, and we get this nice percentage sign in the formatting at the end. So that's really easy to create, right? So demonstrating how DAX works in calculated columns is really easy to do. The convention is if I refer to a column, you always put the table name in front. There's different reasons for that. And while it is a calculated column, the calculation is done row by row. It means that like the formula is taken, and for every row in your table, the calculation is executed and evaluated, and then it's statically persisted in the data model. This means the more columns you add, the bigger your data model gets, because it has to be stored in your data models. The PBX file grows, the size of it, the size of the memory footprint grows, and also the refresh takes longer. These are the reasons why you usually try to avoid creating calculated columns, but use measures instead. We'll talk about them later. But the most important thing is that for the calculated columns, it's easy for me to demonstrate the row context. The row context means that I just refer to the price column, to the quantity column, and then it's executed row by row. That's the row context. That's what we're having in calculated columns. When we use those columns, if I jump over again to my demo machine, I jump in here and get this report here, page report already prepared here. Then I get my, for example, I take the date, and then I add my quantity, my price and my quantity. Let's do it in the same order, not the product ID, but the quantity. And then we had the sales amount. Then we had the total costs subtracted from it to calculate the margin percent, right? So we get like the sales amount, a column which was previously not there. I created, right? 10 times 3 and so on. So we got those numbers. We just have seen a table. But additionally, we get this cool thing here. Maybe remove this first here. We get this also the sum here, right? So 30 plus 20 plus 120 plus 500 equals 670. That's what we get in here. And for the total cost, we're just subtracting things. And again, the margin is calculated. It could be calculated as difference of the sales amount and the total cost would end up in 205, or I can add up the margin like those numbers. Both would equally come to 205. So this works. How does this work? Because I did not, in my formula, right, for the sales amount, I multiplied the price and the quantity. I did not specify anything how this should be added up or if it should add it up. And the thing is, there's a thing called, yes, I will share all the files, Karima. Yes, I will share all the files so you can have everything like the examples and the PowerPoints. So what we're getting here is like I only define the multiplication, but there's something called implicit measure. So if I click on the column, over the column tools in my ribbon, I can see that by default, obviously by default, because I just created this column for you, this default summarization is sum. So with this, it knows that it has to sum up those values when it's represented as in a total, for example. Yeah? And the same is for the margin, right? For the margin, it doesn't really matter. The margin could be calculated like this way or this way, but again, this is a calculated column. So we do the subtractions row by row, which are stored in the table. And then at the very end, again, the margin has this default summarization here. So the sum is calculated. So I get the 205 is calculated like this way, not this way. Very important that you understand this fact. So because we have something which is called an implicit measure. So if you can create something which is a numeric column, maybe we created this as a calculated column, or we create it in Power Query. The Power BI add has this extra property for a column, which is called default summarization. The measure itself is not visible, we can't see it, but it's like calculated like this. So we have either sum, average, minimum, maximum, count distinct when we create it in the model. In the report, in the visual, if you add it into the visual, we have even more options. We have also the sum and also the standard deviation, the variance, and the median. For some reason, the count and the count distinct is in different order, which confuses me, but this is how it is, right? And then this a measure is created for you, but you should not use that, right? This implicit measure can go away if you use Excel. Some things might be restricted what you can do with this implicit measure. Since October last year, it's already it's accepted. Previously, you could not put it in the field, the field way of the field property of the pivot table. Now you can, but still there's some limitations. And the other thing, if you like have further steps in your career in DAX, there's something called calculation groups. As soon as you use calculation groups, these implicit measures will not work anymore. So stay away from these implicit measures. Very important, great measures for that. And another thing is, if we look at the margin percent, which I already had added here, but I wanted to like extra talk about it. So the margin percent is like the 5 divided by 30 is 16, 5 divided by 20 is 25, and so on and so forth. But down there, we get 109. And the question is, can it be, right? Can it be that the margin is 109? What does the margin percent mean? It means that I earn some money from my customers, right? That's my revenue, that's the sales amount. If I subtract the costs, right? So I can keep something, right? And what I can keep in relation to what I got is the margin, right? So a margin from 109% would mean that I receive 100 whatever money currency from your customers, and then you can keep 109 out of those 100. This would be a really good business case, right? If you're starting a startup like this, let me know. I will be ready to invest, because this is like a money printing machine, right? We get 100 euros and can keep 109 out of that. Wonderful. Unfortunately, this is not true, right? The margin, to calculate right, we must divide the 205 with the 670, right? So if I do that for you, so 205, come on, calculator, 205 divided by 670, that's like something of like 30.6, right? 30.6%. That would be the right number. The reason why it's wrong is because, again, also the margin in percent is a victim in this case of the default summarization. So sum is calculated here. So it's summing up those percentages, and this gives a ridiculous number. Some say, in this case, yeah, of course, you cannot sum it up. Let's make an average, right? We can have like an average calculation here, but still, we get a wrong number. 27 is not what we want, or what's correct. The correct number would be 30.6, right? So this will not work. The cool thing is we have a solution for that, and the solution is work with measures. Don't do any calculated columns, but create measures for that. So I will now create everything as a measure to show you that it's way better to have a measure for that. And the measure I can either add in the sales table, but unfortunately in the same table, I cannot have a column and a measure of the same name. So what I'm going to do is that I look for my hidden things here, view the hidden. I will get the measures table, and here I will create this measure just for the simplicity of having the same name, right? I can now have like my sales amount, which is the price, and then there got this surprise, right? I cannot select the price. IntelliSense doesn't offer it to me because now we are in a measure, and the measure works in the filter context, not in the raw context. So it thinks, yeah, if I would access the price column, right, there might be more than one price. So what do I need to do with those different values there, right? And that's the thing with a measure. That's how I imagine a measure. It's looking at the whole data model, looking at all the tables, what's left after the filters are applied. That's what we call filter context. And then I got several values, right? And I have to announce to DAX what do I want to have, like the smallest one, min, the biggest one, max, or like an average or whatever. So what I do here is like I have to apply some calculation here, some aggregation here, and then I can access the price, right? Sales price times the what was it? The cost, right? The quantity. So similar formula, at least up to now. We'll talk about this later, that there's some problem I just introduced voluntarily. So then the margin would be the sales amount. So it's the sum of the sales amount. Again, the same thing. The sum of the sales amount by column here minus the sum of the total costs. And finally, I create another one, which is the margin in percent, which would be the margin, which can be like I can also access the measure here divided by the sales amount, the sum of the sales amount. So I can mix things here if I want, right? And if I duplicate this thing here and do the same things like I previously did, the margin percent and sales amount, and now add my or like jump back here. So this was wrong, right? This average, and now I put in my measure, and I make this measure also where is it? Margin percent measure tool. Here we go, a percentage. Then we will see like per row it's the same values. So obviously this is right because we already proved that this is right. But now also for the total it works because in the measure we now specified that we need the sum of the margin. Maybe I also write it here, like to make it more explicit. We need the sum of the margin, which is like this value here, the margin, the 205 divided by the sum of the sales amount, which is the 670, and then we get the correct number. So this is what we can do with measures. We can't do with calculated columns. So measures, if you access measures or refer to measures, we don't put any column name, table names there, just omit the table name. The reason is you might later decide to move those measures around between tables, which does not do any harm to the calculation, so the result will be the same. But if you refer to the measure in a certain table and you move it away from that, then you get an error message, right? So omit the table name there. And I imagine a measure as something which lives detached from the data model. Yes, we have to create a measure inside the table in order to find it in the UI, right? I have to attach it to one of the tables. But if I move it around, so for example, it's margin in percent, right? I can just say the home table should now be the date table, which doesn't really make sense, right? But you see the calculation is the very same. So it doesn't do any harm where the measure sits. So the only true answer where should the measure sit is ask the people who work with your semantic model, right? Some want this explicit measure table, some want it together with the fact tables. For the calculation, doesn't do any differences, right? Ask the people where they will look up the measure and then put it to this table, where it makes sense for the domain experts. But a lot of filters are applied, or like all filters are applied, right? It means if I write sum of sales amount, it's not, as you just have seen, it's not always like the 670, but for the calculations of the margin, obviously, it's taking the sum of the sales amount, which would be the margin, for example, would only be 5. 5 divided by 25, right? 5 divided by 30 is 67. So sum doesn't mean always that I'm referring to the total, but to whatever can be summed up in the current filter context. That's the filter context. And we have a filter context here showing like the first of something and the price and this quantity. And for this row, only 30 is available. So if I sum up this one row, then the sales amount is 30. So 5 divided by 30 and not 5 divided by 670 or 25 divided by 30. It's just inside the filter context. That's very important to know and understand. And the calculation itself is not saved in the data model. This means if we can add as many measures as we want, I heard about a limitation, so up to like 1,000 measures, then something at least 2 years ago, this could be a problem for Power BI for some reason, but maybe then we have different problems anyways if you have so many measures. But up to this amount, it doesn't really change the size of your model because the result is not stored with the PBX file. It's calculated on the fly when I put it into my visual. This means like this margin in percent is calculated 1, 2, 3, 4, and 1 for the total, right? We have 4 lines here and the total, so 5 times. It's calculated 5 times, and difference in numbers is because in every row and also the total, there's a different filter context. In those rows, we have like on the date and price and so on, a filter. In the total, there's no filter at all. That's why it's summing up everything from the table. So this is very important, the filter context. So So if you compare these, right, in the calculated column, that's why I introduce, when I do introductions to DAX, I always show the calculated column. Not because you should add calculated columns to your model, but because it's easy to see how the raw context works. Because we put in a formula, right, and in the table view, we just have seen the calculation, and we can also see that we can just refer to price or the quantity. We cannot in the measure. In the measure, if I try to access the sales amount column, it will not allow me. It will say, I don't know what you mean, right? Because we have to aggregate things. Usually you put a sum on things. That's the aggregation function you will mostly use. That means I want to sum up the sales amount. If there's more than one row available for the total, for example, or for one day or for one product, then please sum those values up. And the sum means it's a filter context, right? It's not the sum of the total of the whole table. It's not always 670, the same number, but depending on what kind of filter context I applied for the visual or the elements in this visual. That's the filter context. But with this aggregation function, we have a problem, right? If you look on the sales amount column measure, if I add the sales amount measure, let's put it here again. So we put the same things with our measures. So price times quantity, if you remember, was like the formula for the measure. If I put it here, then we get like 10 times 3, 30, 20 times 1 is 20, 30 times 4 is 120, 100. This is correct, right? Correct numbers. But down there in the total, we get this ridiculous wrong number, 2080. Remember, what's the correct number? The correct number is this number. We already calculated this, right? 670. So in the calculated column, the result was correct. In a measure, like the same formula, it looks like the same formula, but it isn't. This is like what I told you. Calculated columns and measures are completely different. It looks like the same formula, price times quantity, but it is not. Why is not? Because we wrote price, sum of price. So what it's doing here, in order to calculate the 2080, it's summing up the quantity with the 13, but it's also summing up the prices. So if I calculate for you again, like 10 plus 20 plus 30 plus 100 is 160, and if I multiply this with 13, we get to the 2080, which is like mathematically correct, but in this business meaning, it doesn't make sense, right, to sum up the prices and then multiply with the quantity. This will be like if you do your grocery shopping, right, and you buy apples and you buy bananas, and the apple costs 2 euros and the bananas cost 3 euros, just to come up with some number, then you would add up those numbers, right? 2 plus 3 is 5, and every piece of fruit, no matter if it's an orange, a banana or an apple, you would multiply by 5. And this is wrong, right? We have to multiply the amount of apples with the price of the apples, and the amount of bananas, the quantity of the bananas, with the price of the bananas. So it's really important that we first multiply and then add up the numbers. And this is what we see here, right? In the calculated column, we had like this calculation per row, right? And then afterwards, we have this, here we go, this calculation, this default summarization where it's summed up, right? In the measure, we happen to specify it the other way around. We ask for please first add up those two elements and then multiply the result. And this does not work, right? It makes a difference if I first multiply and then add up, or first add up and then multiply. There's an execution order makes a difference here. So this is wrong. So how can we rewrite this? And fortunately, there's something called iterator function. So what we need to do is I will write, just take this and correct this. So this is sum x, and sum x is just the long version of a sum, right? Everything you can write with sum, you can also write with sum x, but sum x can more. For sum x, I can specify a whole table I want to iterate over, right? And then ask for please take the price of this table, because I'm iterating now over the whole table, and multiply it with the quantity, right? So times quantity, right? So now we get the correct number here as well, because sum x, obviously, right, iterates over the sales table, and by it iterates, I get a row context, right? Here I'm just referring to the price and the quantity as I did when I created the calculated column. So inside of the sum x function, there's 10 other functions, which are iterator functions. I always make fun of it like sum x like iterator. I don't know why they put an x here, but this is an iterator function. This means iterator function has two parameters usually, one table expression, and then you iterate over those table expression, and then you have like a row context and calculate price times quantity as we did in the calculated column. So this is why you need to understand, even if you don't work with calculated columns, you need to understand the row context, because inside the measure, you can have and ask for a row context through this iterator functions. And this is very important. If you do multiplications in your formulas, think again. Don't just add up those elements, but most probably you will need something called like a sum x or a min x or like a max x for the biggest value. There's even like a product x. I can't remember 10 functions. Yeah, usually sum x, min x, average x, count x. Those are the ones I usually use. Not all of the 10s. Thank you, Bernard. Yeah. Okay, so this is how we. That's why we need the sum x, right? Internally, sum is always transferred to a sum x. So even if I write sum of price, internally it's done a sum x over the sales table, and then I just have like the price, right? So if I do a sum of price, it would execute this thing here. So there's no difference between writing sum x or sum, right? There's no performance penalty. There's always like always once in a while on LinkedIn or somewhere I get like this messages or see like people pointing out that like one is better than the other because the one is faster because it's not iterating. Also the sum needs to iterate, right? I cannot add up numbers without like looking at the single numbers, right? How can I add up the value of a table with sum? How can this be faster without just looking at the individual numbers? Of course, we have to iterate over the table. So this is how sum x works, and come to our saving us, because with this we get like inside the measure, right? But we have a row context inside the measure. And at the very end, I ask for sum x to sum it up, or min x to pick the smallest, 20, right? Or multiply those numbers if I really need to. So to add up to the overview we previously had, is like in the calculated column, I have a row context, which means I can just access the price and the quantity because there's only one price per row available, right? It exactly knows what price I mean because for each and every row, there's only one price, one quantity available. Can just multiply the numbers as we do in Excel, right? In the filter context, the story is different. I'm looking at the whole table. The measure is not sitting or iterating automatically over a whole table, but looking at the whole table and then now looking at like several sales amount values and several total cost numbers. And then I have to specify what to do with those individual numbers. This works great for everything which is like adding up or subtracting it, also for dividing, right? With the calculated column, we had this problem. Dividing things would mean that I first divide and then later add the results, which usually is not the right thing. So I really lack good examples on how to demonstrate how when it would make sense to first divide and then add up things. Usually you need first to add up, for example, the margin and the sales amount and then divide those two things. With the multiplication, it's the other way around usually. Usually you need to multiply individual values row by row and then add the result up. You can do this in row context in a calculated column, and with the iterator functions, we can also do the same inside the measure. So now we see like this is a very same example as we had here, price times quantity, also price times quantity. The same expression is used inside the sum x because sum x creates an iterator, is an iterator function and creates a row context inside a measure. That's why it's important to understand the row context and the filter context because both are available in measures. So then as a DAX author, you can also control filters, take it on one level above. So I created a measure called product A, which I created in this way that as I refer to the sales amount column, not column, sales amount measure, of course. And then I put this into the calculate function. And when I can remember the first time I saw the calculate function, I thought about, this is ridiculous, right? Of course, I want to calculate something. Why the heck would I create a measure not calculating something, right? So if it's clear that I already calculate something, why the heck should I put explicit right calculate in front of my expression? And this was a really big mistake I made, or my brain made to me, because the calculate function is the most important function, it's the most powerful function we have in DAX, I would say, because we can manipulate the filter context with that. So I can specify, please calculate the sales amount, but on top of all the filters happening in the report, because there's like filters, slicers, cross filters, everything, there's like things on the axis or rows and columns. On top of those filters, I want to do something with those filters. For example, I can write here, product description should be A. And then there's two interpretations possible. Either people say me, if I have like this table, A, B, C, D, right? And I write this measure. So one way, people will tell me, I only see something for A, so only A 30, nothing here, and 30 at the very end. Or The other result could be that at every single row I see the sales amount of product A. So 30 here, 30 here, 30 here, 30 here, and 30 also in the total. And to some surprise, I mean, there's two possibilities, but more often than not, people are surprised that it looks like this. So if you write a condition here, it's not really a condition, it's overwriting the existing filter. So in this row, for example, let's just take a look at this row, right? We have a filter on product B, and obviously the sales amount for product B is 140, as you can see here. And with calculate sales amount and so on, that's the formula for the product A measure here, it's overwriting the filter context, right? It removes the filter from that there's a filter on B, so it's not showing B anymore, but it replaces it with A. This is what's happening when I write things like this. But it means that I can calculate something like this. The question is though, why the heck would I show like the sales amount for product A in the same row where I refer to product B? And the answer is this is for more complex calculations where you maybe want to relate those products to each other. I want to calculate how much bigger the product B is compared to product A. So for this, I have to access the sales amount for product B or C and D, and also the sales amount for product A. And with this notation, I can access the sales amount of product B and then can relate things to each other. Or think of like calculating how much bigger or smaller you are compared to your biggest competitor or something like this. This is what we can do in these calculations. There's also a shortcut there's a longer version for that, which makes it more easy to understand. So instead of like writing calculate sales amount product A, product equals A, we could also write filter on all the products and then A. So filter again is an iterator function. I pass in a table expression. In this case, I say, please all my products, right? If there's already a filter on the product description, ignore this filter. I want to have all my product descriptions. And from all these product descriptions I have in my database, I only want to pick the product with A, right? So in the end, I get the same example. So the first one, where we only write this condition, is not really a condition. It's like transferred to this notation, which contains this all thing. So that's why if I write it this way, any filter on the product description is replaced with a filter for A, right? So that's what you can do here with these calculations. On the other way around, if you want to achieve something, I only want to see something if the product is A, I just can omit the all thing here, right? So I put just a product table here. Again, be careful when you put tables in here. It's just to make it easy to explain things here. This means that I now look at all the products available in the current filter context. I did not put the all here to remove any filters. I just accept what kind of filter context is here. And in this row, there's a filter context on B, right? And on top of that, there's only one filter in this row, only one product is available, product B. From those products, there's only one product available. I pick the one with A, and B doesn't be A, right? So this means that in the end, for this row, I don't get anything. I only get something if the current filter context and my condition is the same thing, right? So that's a different way of writing this. And again, to make it like easier to write, maybe it's harder to understand because there's different ways of writing things. We could also replace or wrap our condition with keep filters. This would be the very same thing as we just have seen. So keep filters does not remove any existing filter on the product description, but keeps it, right? Keeps the filter on the product description and adds with an AND condition, logic operator, the new condition that it also should be A. So in the end, I only see something for product A. And also the total, right? Don't be deceived. The total is not the sum of those things. The total, just what's different is the filter context is different, right? In total, there's no filter on my product. So all products would be available, but from all the products, I only pick product A and show then the sales amount. That's why I get the 30 here as well. It's also very important that the total is usually not just the sum of something, but it's just the same formula, but calculated in a different filter context. Usually filter context where there's less or no filter available, while there obviously there's at least a filter on A, B, C, or D. If there's any questions, please let me know and interrupt me. Yeah, keep filters. And instead of like adding filters or removing filters, we can also remove filters at all, right? With this notation, I can have a column showing me the total of the sales amount, right? Again, This is nothing I would usually show in a report, but as you can imagine, by understanding how I can remove the filter context and description, I can then calculate. For example, I could divide the 30 with 670, showing what kind of sales amount in percent of the total some products show or have, right? And therefore, I need to calculate like the 30 divided by the 670. And the 670 I can access by removing any filters on the product description. So I would write like sales amount divided by calculate sales amount all product descriptions, and therefore get then a percentage calculation here. And all selected is usually the one which is more useful in many scenarios, or it's more the one which people accept. So the all selected would only remove any filters I have inside my visual, but respect the filters outside of the visual. So if I have a slicer or cross filtering, or if in the filter pane some filter, all selected would respect this filter and only remove it here. So for example, if there's a filter applied, I only want to see certain products, right? Then all would still show me the 670, which would be the sales amount for all my products, not only for the selected product or products, but for everything. All selected is usually the one which people more expect, which means that I only get like the numbers I can see here, right? So if I do the calculations, I still want to see 100% if I select something in here instead of only seeing the portions of the products I selected. Hope this makes sense. So last but not least, it's very important. That's how I can sum up things. So I could stay in time, even if you started like 50 minutes late, according to the 60 minutes I've prepared. So I talked fast enough that we can conclude now this session and then open up for a Q&A. What's the difference between the calculated column and the measures? Because it's so important. It's even so important that you should stay away from calculated columns as much as possible. Use measures for everything. And sometimes I hear people, but of course, I mean, take this example, right, for the sales amount, right? If I store the sales amount, if I store it, right, and what the calculated, the implicit measure, I just need to sum up the values. Of course, this will be faster than doing multiplications in the measure and then sum the things up. But the difference might be way, way, way smaller than you think, right? Physics are correct, right? Multiplication and then summing up is slower than just summing up. But the difference in like in your reports, this might be like milliseconds, right? Nobody will recognize that you put something this calculation into a measure. So my first approach is always to write measures like this. If it's getting more complicated, maybe in some point there's a performance penalty, performance impact, and then I would try like to rewrite my DAX measure, find a different algorithm to make it faster. If this all does not work, then like one of the last resource would be to store intermediate results in my semantic model. But this would be like one of the last steps and not the first step. So if you use, for example, Excel a lot, if you're coming from this side of the world, then of course in Excel you store things, right? And then add columns and add columns and add columns to make your calculations done. This is not a very good idea in Power BI because your model grows and then maybe it doesn't fit in your memory anymore or doesn't fit in your Power BI service anymore, depending on your license. You have this limit of 1 gigabyte or 10 gigabytes or whatever for your semantic models. So calculated columns are bad, say the measures are good, so to speak. So calculated columns, if you create them, it will increase the refresh time of your model. That means if you refresh the model, everything is read from the data source. If it's done, ready with that, then it's recalculating all those columns. There's an extra step done for every single calculated column. And also the model size grows because it's then stored in memory. If you hit save, then it's also persisted in the PBX file. For measures, there's no influence of refresh time because on refresh time, the measures are not looked at, right? They're only looked at if you're referring them in the calculated column, then maybe, but then it's the calculated column's fault. Or if you use them in the report, yeah, this is much later, right? The refresh does not know when you hit refresh. Power BI ignores the fact that this will be later used in a visual, for example. Refresh time is not influenced, nor does model size. Of course, like the text you write, the formula has to be stored in the PBX file, but comparable to the data, this is usually neglectable. So calculated columns, as they increase the size of the tables, you should only apply this on small tables. This means maybe if you have like a dates table, then maybe create this as a calculated column table, and then create calculated columns there, because it's like 365 rows per year, 10 years, not even 4,000 rows. No deal, right? No big deal. But if you create a calculated column on your fact table, where we talk about thousands, hundreds of thousands, millions, billions of rows, right? This means every byte you add there is added for every row. So with 1 million rows, this is like just 1 megabyte per byte you're adding there, right? So don't do that. For measures, we don't care, because it's not adding any size to the table. So you can add this to small and big tables as well. The formula of the calculated column is evaluated during refresh time, not during the time when you build reports. So all the filters you put on are not put on the calculation of the calculated column. They're only put on either the explicit or implicit measure. So if you show something in your report, in your visual, then maybe only certain results of your calculations are added up, right? But inside the calculated column, they ignore any filter slices because it's not available at this point in time. Measures, on the other hand, they are reacting to the slices immediately, because it means the measure is calculated in a filter context, and filter context means that all the filters available in the visual on the report page are respected. That's why we see different results every time you change a filter. Then also the measure has to be recalculated, and most probably a different number will come out. The formula in the calculated column is heavily depending on the hosting table. This means if I cannot just copy and paste from one table to the other, because most probably in the other table I have different column names, different table name, right? This will not work. For the measure, this is totally independent. I did already demonstrate this, right? You can just move the home table, change the home table for your measure, and then you can move the measure around. So it's not very important where to host the measure. It's important for the people who work with that. So ask them where they will look up the measure. You can directly reference columns of the same table. If you reference something, a column in a measure, you always have to apply an aggregation function. For example, sum or min or max. Those are the ones I often use, right? Don't keep the intermediate results for the calculated columns, because this adds up the size, right? So if you build up things, maybe you do it in several steps, but at the very end, before you put it into production, remove those calculated columns and inject the code directly to the resulting calculated columns. For measures, you can have intermediate measures, as many as you want. They will not really impact any of the performance or the size. And calculated column, they have this implicit measure, which work in Power BI, work somehow also in Excel, but have limitations, and also can have limitations that don't work anymore in Power BI when you use calculated columns. So please stay away from that. Use explicit measures like right click and measure. So with that, I'm closing like 1 minute earlier. Are there any questions?
Hey, Marcus. Thank you very much. I don't see any question. I guess it was, of course, it was very informative, and lots of tips and tricks. The cheat sheet. So, and as Karimat said, it is maybe good to have those files to practice, with those, basically tips and tricks, with those files. It is, especially when we are working on Power BI and DAX and all of those tips and tricks. It is good to just pause the video, go on the Power BI desktop, and do and actually replicate that and practice that. But yeah, thank you very
Shall I
much.
share the file with
There's
you, or just
a
put it into
question
LinkedIn?
here. Yeah. Oh, awesome. The question here is this
Applies also to
Apoyo
analysis services.
analysis
Yes,
service.
yes, it also applies to analysis services. Tabula, to speak, right? Not multidimensional, but analysis services. Tabula also has the same DAX. Like the versions might be somewhat different. So like the newest version or the newest function may be not really available in all the versions of analysis services. There might be differences, but the principle, everything I showed here, also applies to analysis services. For the files, shall I send this to you? meetup, or shall I just put a link on the LinkedIn?
Uh, you can actually share. You're gonna share the
Yeah, yeah.
link or something. Do you
I put
have it
something into zip
somewhere?
file where I
Yeah,
put in
yeah. Maybe you can.
the slides, and this file I just use for the demonstration, and everybody can.
What we do basically is, we are going to share the recording on
Hmm.
a YouTube channel, in
Hmm.
maybe next week or sooner. Then, of course, we're going to tag you there. Then you can share the link in that,
Yeah, sure. Yeah.
thread of
Or you
of
can
the.
put in the description,
But
right?
yeah, thank you very much for your time, and again, thanks everyone for joining. It was a great session. Marcus just finished in 1 hour. Great. I'm going to. This session is almost done. It is going to be available, as I mentioned, on our YouTube channel. Of course, you need to rewatch it, pause it, and practice whatever that Marcus you know uh, taught us. And for next session, we also have Marcus next week. uh, Joe, I will come to your question soon, but next week it is going to just talk about star schema and Microsoft Fabric, how to become a guardian
And
of the
Java has
star
a
schema.
question about
I'm
that. I
super
will answer the
excited for that
question
one.
next week, but the short thing is I use bridge tables, right? So I avoid the many-to-many relationship.
So the question is for those who doesn't see that, what is your preferred approach to many relationship between
Exactly, yeah. That would
tables?
be the bridge
Yeah,
table. That's a
it's
sneak
going to be
preview,
answered.
so to speak, and I will also talk about that next week, I guess. Depends on how much time I will have, yeah, if we come into many-to-many.
Awesome. And just one more thing, as you know, what's I wanted to mention about? I forgot. Sorry. Anyway, thanks for attending. Stay tuned and follow us on our social network. So it is the YouTube channel, LinkedIn, and the Microsoft Community Group and Meetup. Just rate the session, today's session, and Meetup, and also follow us on Reddit for having further discussions. So with that said, we have some thanks from everyone. Karima, thanks everyone for joining. Santa and Rima. Awesome, awesome, cool. Marcus, if you have anything to add, feel free. If not, we can wrap up the session and wishing everyone a
Yeah,
great
thank you
weekend.
for your